Hi everybody, my name is Zhao Dong. I'm the mentor for this class, self-driving car. I'm a PhD student in Washington University in St. Louis. My major is in computer vision, deep learning for biomedical imaging. So today I will give a brief introduction on what is a neural network, what is deep learning, and what can you do with this new technology, what is the application, and what you can learn from this wonderful class in Udacity. So nowadays, neural networks, deep learning, machine learning is so popular and so hot topics. A lot of industry areas using these new technologies, new networks for their products of different applications, right? For self-driving cars, for robotics, for biomedical imaging. And the results are amazing. So people are wondering, what are these? What is neural networks? Where did these things coming from? And what can we learn from this self-driving car class in Udacity? And what can we do with these neural networks? So let's start our lecture for today. After this, you have a basic idea about all these questions. So the neural network was coming from the idea of biological neurons. Here I show a picture of biological neurons. We can see the neuron cell has a lot of input. And the input signals will come into the neuron cell, and the neuron cell will do some processing in your brain or either your body, and then they will give an output signal to the other neurons, or even to control the muscle inside your body. So people think this is really wonderful. So they came up with an idea. They built this mathematical model to imitate the neural networks. So on the left picture is a simple neuron. So we have 3 input on the left, and each input has a path. For different paths, they have different weights. And the input will multiply with the weights and then go to the neuron cell. The neuron cell will do a summation to plus all of these input together and give output. So this idea was invented in 1969. And later people realized this is too simple, and we can stack multiple of these neurons to build a larger neural networks to achieve better results, to do more complicated education calculations. So we have multiple input layers on the left side, and besides the output, we have hidden layers, and you can choose how many layers or how many neurons in the hidden layer, and the hidden layer will go to the output layers. So for each of these neurons is exactly the same like as I showed in the left. So we can do different calculation between different neurons and different paths. So we can add different hidden layers to really build this neural network very deep. But all of these only use multiply and summation. It's too simple. It's not enough to use these simple linear mathematical operations to describe the real world stuff, right? So people later invent convolutional neural networks. So from their name, the convolutional neural network means we will do convolution during the process. So we have input image. We have different kind of convolutional layers. We will multiply the convolutional layers with the input image and have some for different outputs. We will do other mathematical operations like the poolings. We have average pooling, we have maximum poolings. And the output will go to the neural networks we just talked about and give the output. So with all these different mathematical calculations, operations, we can extract a lot of features from our input images. For example, you can extract a simple feature like what's the shape of the object inside the image, and what is the boundary. And with convolutional neural networks, you can even extract some high-level features which people don't understand directly from the images. But all of these features can help us to better understand the real world and really do some mathematical calculation to achieve for different applications. So then what we can do? This is our next topic. So the first application, we can do image classification. For example, we have an input image here. We want to know what's inside this image. Then the convolutional neural network will calculate the feature. For example, they calculate what's the boundary and some high-level features. And the output is some probabilities for different categories. For example, for our car image, 95% is belong to the first categories, and the first category is a car. So it correctly tell what's inside this image. So for this, we can use for our self-driving car to do the traffic sign classifications. Think about this: if you have a camera just in the middle of your car, and they can take a picture to see what's in front of a car. And here's one example image. You can see we have multiple of these traffic signs, and the neural network will do some classification to tell what does this sign means, and the car will understand the meaning of the traffic sign and then take actions correspondingly. So for example, on the right is a real self-driving car images took by the camera, inside the camera. So we can see all the traffic lights was detected, and the neural network tells the car this is a traffic light, and it's called you can turn right or you can keep moving, and the car will understand the real world and do the right thing when you are driving with a self-driving car. Another application we can use convolutional neural network is to do the object detection. So here, this image shows the first one. We have cat image. With our convolutional neural network, we can do the classification. We can know this is a cat image. But we can do more, right? We can localize where the cat is. We can use a bounding box to accurately show the position of the cat, and at the same time do the classification. So another thing, if the problem is even harder, for example, we have multiple objects in one image. In this example, we have cats, we have dog, we have duck. So will the neural network tell the difference? Of course. So we can do the same thing, object detection. We can use the bounding box to localize each different category of objects with different color bounding box, and at the same time we'll tell for each bounding box what's the classification, what's the category belong to that bounding box. Further, we can even not only use the bounding box, we can draw a line of the boundary to segment the object for different objects in one images. For this example, we can do the segmentation to distinguish the background and object independently, right? We call this instance segmentation. So all this object detection technology can be used in self-driving car. And you can learn different networks, for example, the YOLO network, the Retina network, the MAST-CNN network. All these advanced network is based on convolutional neural network. And you can learn how to design all of these and to do this different application for object detection. And you will do a real testing in self-driving cars. Here is one example of the self-driving cars, right? So with a camera, you can detect what's in front of the car. We can detect there are a lot of cars. We can use a bounding box to tell where the location of the car. And we can detect the position of the traffic light. And we can even detect there's a person riding a bicycle here. So with this really powerful tools for the neural network, we can do all kinds of things to help us to better design the self-driving car. And all these things you can learn from this wonderful class, self-driving car. at Udacity. So I really enjoy to be a mentor for this class, and let's work together to really make things happen and to really build your own self-driving car model can drive the car automatically. Thank you very much. See you next time.